Assalamualaikum warahmatullahi wabarakatuh. My name is Isul Shazaliman Ali and I would like to talk about assignment 3, question 1. So, question 1 said that a piston cylinder device whose piston is resting on the set top uh, initially contained 300 kilogram of air at 200 kilopascal at 27 degrees Celsius. The mass of the piston is such as the pressure 400 kPa is required to move it. Heat is now transferred to the air until its volume is double. Now, first and foremost, we will bring out every information given in this paragraph, which is P1, P2, mass, temperature at degrees Celsius, so we at 273 to Kelvin, and we will draw the uh, free body diagram. Question first A asks that to state the energy balance associated with the system. So we will get E in minus E out equal to E system, which is E in and E out equal to net energy transfer. E system equal to change in initial energy. So we will expand it to Q in Q out. WP in minus WP out equal to mass times U3 minus U1 U1. So there's no U out. We will see from the free body diagram there is no Q out and there is no work boundary out. Work boundary in. So that left us with Q in minus work boundary out and M times U minus U3 minus U1. Since work boundary is a change of internal energy, so we will put it we will put it right here. So leaving Q in at this before. And then question B asks to show the PV diagram. This is the PV diagrams that we will draw. The reason why, because from 1 to 2, the volume is constant, is the pressure piston requiring 400 kilopascal in order to move, and from 2 to 3 is because the heat transfer in the air volume is double. That's why the pressure will be constant at that point. Now, C said to determine the final temperature of the air. So we'll find the final temperature, which is to be T3. So T T1 we need to find from the T1. We don't have any we don't have T we don't have temperature at T2, so we need to find it. Since volume from 1 to 2 is the same, so we will to use this formula V1 equal to V2. So V1 equal to P1 over temperature, same as V2 pressure over temperature. So we need to find the temperature at 2, so we will convert it to P2 over P1 times T1. We will find 600 K as second state temperature. So to find the final temperature, there is a catch in this part where at V3, it tells us that the transfer to the air unit is since now the pressure plate can be moved, the transfer to the air volume unit is double. So V not so since that statement V3 is count as twice as V2. So we will find the same using the same principle V2 over T2 equal to V3 over T3, but since that we will change V3 to 2 times V2. Since we have 2 V2, we can cancel both of them and get T3 equal to 2 T2. We get in the number of T2, which is 600, we will get a final temperature equal to 1200 Kelvin. Question D. D asks to determine work done by the air. So, um, we had R, which is the constant of the air. We get at table A2, which is 0.287. We will use R in the equation of V1 equal to MRT1 over P1. We insert the information that we got, and we got the V1 equal to 1.2915 meter cube. So since we know V1 equal, since we know volume 1 and volume 2 is constant, both is the same. So V3 equal to 2 V2. So since at volume 3, we will know it will become 2 times volume 2. So we'll be find volume 3 by make it 1.2915 times 2 equal, we get the final volume will be 2.583 meter square. I sorry, meter cube. Now we'll find the work boundary. First and foremost, we need to find work for from 1 to 2. Since there's no move, there's no expand in velocity from 1 to 2, so the volume will be 0. So this work done to the boundary will be 0 for the first from system 1 to system 2. However, from there on, we need to use the WB out, WB out equal to P2 V3 times V3 minus V1, which is we need to find this, and then we key in the formula 400 times 2.583 minus 1.2915. We get a final answer of 516.6 kilojoule. Since this is the only answer because of when 600 plus when 516.6 plus 0, we will got 516.6 kilojoule, and this is the final work done to the boundary. And next, final question, it asks to total heat transfer to the air. So for that, we need to find U1 and U3 first. U1, we'll find both of these value at table A17. So U1 at 300 will be 214.07, and U3 will be 933.33 kilojoule over kilogram point K. So using heat transfer formula, which is the formula that we derive, we will get Q in equal to we get Q in equal to 3 kilogram times 933.33 minus 214.07 plus 516.6 kilojoule equal to 2674.38 kilojoule. This is our heat transfer. Now this is our heat transfer. Now we'll go to the second question of this assignment, which is a long cylinder steel rod, rho 7833 kilogram and CP equal to P 0.465 kilojoule of 8 diameter are heat treated by drawing them to a velocity of 2 meter per minute through an oven maintained at 900 degrees Celsius. If the rod in the oven at 300 degrees Celsius and leave at a mean temperature of 500 degrees Celsius, determine the rate of heat transfer to rod. So we, same as earlier, we bring out all of the point that we got, and we draw a free body diagram. First, we find E in minus E out equal to E system. We will derive it to Q in equal to M U minus U1. Then, since there's no U2 and U1 in here, we need to change it to CP times temperature 2 minus temperature 1. So, as we know, it doesn't give us the mass for this equation. Since we need mass for it, we will find the mass from the rho, which is rho equal to mass over volume. We will find the volume since this. So we will find the volume. Volume of cylinder is length times area. When formula for area is pi d square over 4. We put in the number, and we'll get to find this as the mass of the rod. Next, we put in our number to the Q in formula. We will get this as the heat transfer, and to find heat transfer rate, we will divide Q in over delta T equal to 1.73 times 10 power 10 over 60 seconds. We will get 286831958.3 kilowatts. That's all from me. Thank you.